Okay, so I have a drag force here. I have a mass. Let's say this thing has mass m. Maybe it even says up there. It does. Okay, if I pick that way as positive for my coordinate x, that way is positive for v, that way is positive for a. And so from what is effectively an isolation diagram, I get the equation of motion minus k v squared is equal to ma sub x. There was something I was supposed to remind people about. Yeah. Yeah, remind me after. Okay. So, a sub x, x double dot, is also dv dt. That's what I'm going to want to use. So I'm going to reverse the order here and say dv dt is equal to minus k over m v squared. So this kind of drag, this quadratic drag, is appropriate when things are moving fairly swiftly. And it says that the retarding force is large when the velocity is large, and then it gets progressively smaller as the thing slows down. So it may actually take it quite a while to come to rest. Okay? So I can't just multiply dt and integrate, because v is not a constant with respect to time. So I have to separate the variables, put this v on the left, 1 over v squared dv dt is equal to minus k over m. And now I can, if I like, multiply both sides by a little interval of time and integrate. So what limits should I pick for the integration? So it starts, are we told what it starts at, like v naught or something? Yeah, well, yeah, v naught. Okay, so this is an integral with respect to, what's the integration variable? As written. T, right? So this would be from time 0 to some time t. For the fussy, I can then put a prime as the dummy variable of integration. But I'm going to want to get rid of the t prime and convert this into an integral just over v. Is this a legal maneuver here? This side is easy. This side is minus k over m times t. So is that a legal move? No. What's wrong with it? The limits have to be expressed in terms of the variable v. So that's not a legal move. I erase. What limits now should I be using? Some v naught up to a v that's going to correspond to that time t. Agreed? Okay. That's in the class of integrals we know how to do. So we have minus 1 over v to be evaluated between the limits v naught and v of t is equal to minus k over m t, or 1 over v naught minus 1 over v function of t is equal to minus k over m t. So multiply through by minus 1 and throw this term to the other side, and we have 1 over v is equal to 1 over v naught plus k over m t. Now we flip. V of t is equal to, you know, before I do this flipping, I think it makes sense to do a little factorization. What should I pull out of the two terms on the right? Yeah, I think if I pull out a v naught, so I'm going to leave this as that way, 1 over v naught, then the first term is 1. And what's the second term? Plus k v naught over m times t. So now when I come to do the flipping, I get v of t is equal to v naught over 1 plus k v naught over m times t.